Hi and welcome. This time around, my project is to make some new snugs for my mag base that holds my camera. This is just some hot rolled steel. These snugs, the ends rotate, and since I take the camera in and out, a shaft in and out, they're never aligned the way I want, and it's nothing but a pain to use this. Plus, if you notice, the snugs overly bend in order to cinch down on the bar on both sides, which is crazy. So we're going to make two new cinches, one for this 3/8 inch shaft and the other one for the .467 shaft. And we're going to replace this main shaft here that's 3/8 hot rolled that I sort of cleaned up with some sandpaper, and we're going to replace that with some 01 tool steel that's hardened and ground, so that should make it much smoother. We're going to make two of these snugs, one for the base with the larger diameter and one for the top with the smaller diameter. The material for the snugs part of the shaft is going to be 01 tool steel. However, I didn't have some big enough pieces of tool steel to make the bottom part of the snugs, so I'm going to have to use this cold rolled, and maybe in the future get a bigger piece of tool steel, but that stuff's really expensive. So here's my new task lighting in place and already helping. So just got to cut out two pieces, rough cut. Be right back. Here's number one. Here comes number two. So you saw me cut out these two pieces, and I took them over to the mill and machined them to size. And pretty much right after I did that, I started reconsidering my design. So in this design, I was looking at 1/8 inch walls because of the outside sliding piece, which would be equivalent of this guy, this part right here. And I was thinking about making it 1/8 inch walls so it would have a lot of bearing surface so I could put a lot of force. But the more I thought about it, it required really large stock, 1 inch across, and I thought it was kind of overkill. So as usual, I rethought my design, and I came up with a slightly smaller, thinner version. So now I'm down to 1/16 or 62 thousandths walls, and that allowed me to use some tool steel I had. Just going that little bit smaller made it so that I had some tool steel in that size. So I'll be able to make the this side snug piece out of tool steel instead of just plain old cold rolled like this, or hot rolled, whatever it was. So I'm going to pursue that. However, the thinner walls makes it so that drilling is going to be a bit more challenging. I don't know if it is going to want to deform, so I might have to make a fixture to hold these parts while I drill them. So it's a trade-off. The other one would have been probably stiff enough to not need that. So next step up, we'll go over to the lathe and we'll take some of this stock and we'll hollow this piece out and tap and thread the end of this guy. And the reason why I chose bars this length rather than cutting out pieces is this way I can make one part on each side of this and flip it around in the collet as I want to make the part, because you got to remember when you're doing these projects, you've got to have something to hold on to. So that's not always obvious and not always easy. So we've loaded our 1/2 inch stock here, and we're just going to face and chamfer the edges on the first side, and then we're going to drill and tap for 1/4-20, and then we're going to flip it around. We're going to do the same thing again. That way I get two pieces out of the one shaft with one setup, and I can always hold on the center part of the shaft. Next up, we're going to tap. I'm going to start with this starting tap, and then I'm going to finish with this modified starting tap that I've now turned into a bottoming tap. Continue with bottoming tap. These are pretty shallow threads, and to be honest, I would have preferred quarter 28, but I couldn't find any knobs in quarter 28, and I didn't have time on this project to make one, although that is definitely a consideration because that would turn out much better. Next up, I'm just going to put a mark outside to indicate the end of this part, just so I'm working on it. I've got a visual reference, plus I'll use it if I decide to make the tool fixture for it. So we're just going to put a little tiny slot. Alright, now as I was promising before, we're going to pop this guy out. And flip it around and repeat after I take the burr off here. So here's my finished first part, threaded ends, 2 duplicate parts that I'll finish one side, flip it over in the fixture, do the other side, and then eventually part them off with these parting lines. Alright, onward to the next part. So on this guy, we're going to hollow out the center. So what we're going to do is we're going to drill, and we're going to work our way up to just under 1/2 inch, and then we're going to ream just over 1/2 inch to about 1 1/4 inch depth, a little bit more on this. So the wall is going to be about a 62.5 thousandths or 1/16 a side. So it's going to be fairly thin and delicate. So I'm working in a little bit of unfamiliar territory, as I often do. So we're just going to give this a shot and start with center drill. Then we're going to go through 1/4 inch and then work our way up. My intentions here are to step up in drill bits so that we're taking off less material than we would normally do each time, so that the forces on the piece are less. So I switched to my 3/8, which is a carbide tipped, because I was going a little bit fast, and I think I hardened the steel inside there about 1 inch in. So now I'm taking a full bite with the carbide, because the other drill bit was not going anywhere. I've slowed the wave down quite a bit. So with this tool steel, I had to slow down even more. To 70 RPM. I used a high helix drill bit because I'm going so deep, but the problem with a high helix drill bit is that the center section, I forget the proper name for that, but the center part of the drill is thinner than a regular drill bit, like this one, so there's more flex, so you have to be careful, but it does evacuate chips better, so it's sort of a trade-off. Last step, we're going to ream to 0.502 because that's the reamer size I have. I think I prefer 0.501 for even snugger fit, but we'll go for 0.502. This is a carbide tip reamer, and we're going 70 RPM. And we're just taking off a total of a 64th. Between two sides, so 128. So here's the 1/2 inch piece, and if I was worried there was too much slop, there is the tiniest bit you can feel. That's the 2/1000ths over, but it's pistoning, so I think we're good. Now I'm going to flip this guy around and do a second one. So I wasn't going to show you this originally, but this is the second time around, and I am going much slower this time. I started much slower because But this tool steel, I think when I got in kind of deep, the tip was rubbing because the chips packed a little bit, and that would cause a lot of excess heat, and the excess heat would cause the material to harden. So I think that's what happened, and required a carbide bit ultimately to get in there. So here's what actually happened. It wasn't that it was hardening. I was getting significant buildup on the tip of my drill bit on both sides, which would prevent it from cutting and then getting hotter. So maybe it was doing both, but in any case, got to be very careful. So definitely not go too fast with this tool steel. So really slow speeds weren't a lot better. This is my carbide drill bit. As you can see, it's a new shape I've been developing called catching and braking. So even at really slow speeds, this stuff is problematic because it tends to turn up a burr and then catch, and it shattered the blade. I'm going really slow speed with a continuous feed, but not too fast. Really challenging doing deep holes in this 01 tool steel here. I'm sure with more experience I do a better job. It's a shame I ruined a really expensive drill bit. Alright, so here's this guy done, both sides, and we can get ready to take it over to the mill. So we're going to make a template to help me cross drill, and to do that I am going to drill all the way through this part, starting with a 1/4 inch, just part way through, then this guy all the way through, followed by a reamer at 1/2 inch, and then I will follow that up with part way through with 5/8, and that will allow my two parts to be seated on axis with each other. So I'm going to be creating two holes along the same axis, and as you can see there, and then I'm going to mill this block down until I reach the midpoint of those holes or just under, and I'll create the fixture to hold the parts. So I'll start with stubby drill, and we're just going to go in part way. A little high RPM, I guess. So I know that I don't need to be as accurate as a reamer is, but we're doing it anyways because we can, and that's what I've been trying to do with all my projects, is be as accurate as I possibly can, even though it doesn't call for the kind of accuracy I'm giving it. Next up, we're going to use this 5/8 inch end mill to go in 1.25 inches, which is the length of the 5/8 inch part, and we can probably go slower. Let's see. Probably a good speed. Alright, so we're there. Look at this freaking nest of aluminum here. Here we have our block, 1/2 inch on one side, going to 5/8 on the other side. You can see the ridge in there. And we're going to face mill it down until we get halfway, which should be exactly 0.375. This is making quite a mess, so I'm going to bring out the vacuum, so I'll bring you back when I'm done. Putting the final touches on here, the screw down points for the clamps. And that would be it. Nice job. These two holes done right, these two holes not done right. They'll still work, but sloppy workmanship. just got myself in a little bit of a hurry here. Continue the issue with the rocking of these two parts, which means they're not exactly coaxial. I fixed it by adding a 6/1000 shim underneath the short side, and what I found was, I thought it was originally a burr, and there was one tucked under this side, which made it even worse, but the 6/1000 makes it very stable. The problem was that the 5/8 end mill I used, I bought it at a estate sale with a lot of them, and I think it had been resharpened. So I'm gonna have to put some shim stock under this to keep it from rocking while I'm drilling. And I still have to make some straps for these, which I'll probably do off camera. And then I'll come back, we'll strap these guys down and do some drilling. So I've loaded the fixture into the vise, and I've found my 0 point where this guy slides up and butts against the rim, and I'll be inserting the other piece along with the shim from this side, and I need to space this edge out so that the drilling points will be right. So I found the center between here, I found my 0 point right on the edge of this guy. Now I can insert my 6/1000 shim and get this guy positioned right, then tighten it down. Now one more thing, I used some flat stock I had, but it's not the ideal clamp because it's a flat clamp, which means technically it touches at just one point. In reality it's a small surface area, but it's not ideal. What would have been better is if I had bigger pieces of stock to make this part longer on both sides, cut off the ends, flip them upside down, and use those for clamps. They'd match the same diameter, and it would make a much better clamping surface. In case you're wondering what these two parts are, the smaller part here is the inside of the snug that will be pulled against the opposite side of the snug that's going to grab the other shaft. So there's two grabbing points, a sliding part and a squeezing part. The squeezing part grabs the main shaft, but it also pulls at the same time this inner part, which is the smaller diameter here, past the larger sleeve, which is this part right here. So I've got to drill a 3/8 inch reamed hole through that part, which will be the grabbing part and the inner part together. I want them to be very close, so I'm going to drill and ream them. And then the small holes here are only to keep this inner part captive, or rather to keep the sleeve captive on the inner sleeve. So there's going to be an 832 set screw that will just protrude on the other side, and I only need a little bit of slop in the outer hole. So initially I'm going to drill the tapping hole, and I will follow that up when I'm done with the body drill hole. And the point of that is to allow a little bit of slop so that the inner sleeve can slide just enough to grab the shaft. And since I'm going to make that fairly accurate, we're not going to have any problem with you know, range of motion. It only needs to move a few thousandths before it grabs. So let's call this take one. I accidentally bumped the y-axis with my knee and I didn't lock it off like an idiot. And so I drilled off center. So now my fixture and my two ends are fakaked. So we're gonna have to start over, make new fixtures, make new ends, and go from there. So I drilled the holes oversized here, and I used an end mill to do it so that the fact that the other holes were off center wouldn't guide a drill bit. You know, drill bits tend to wander, so the end mills don't as much. So I way over drilled them 1/4 inch and 1/2 inch instead of, you know, much smaller. And it's like a number 29 and 3/8. So anyways, we've got plenty of clearance now, so we can go back and we can, after I make another couple of these pieces, we can come back and work on this. Okay, so here we are with round two. I made another, this time I just hollowed out a whole piece. I could make two out of this if I want to. And I refinished the second side of this one so that I can make two again. So Here we go. This time we're double checking to make sure we are on center, and we have locked our ways off. We have learned from our mistake just this once, and we're going to start with the tap hole again. So this is a really close fit. It's smooth, but I made it a thousandth over, so I want to remove this side now, but it's really tight because the burrs are holding its place. So I recommend drilling a hole all the way through so you can have access, which I also figured out on the second time around. So we're just going to try and tap it out here. Because we've got to shear off the burrs in effect to get it out, so there we are. So I can deburr this out of here. So I got the first one done, and now we're going to do the second one, and I'll bring you back when we're done. So here are the two parts together in the lathe. You can see that there's not much slop here. I went 10 thousandths over because the other one was just a little bit too tight, and it was working, but it made it kind of challenging to feed the 3/8 bar. So this is my little test piece here. So next we're just going to part this guy off. I will say one thing, this 01 tool steel is the gummiest stuff I've ever worked with. It's a lot like aluminum. So one, next up is parting off these two guys. It almost would be easier to bandsaw this and face these. So we cut them off the bandsaw, and now we're just going to face them and chamfer them on the lathe. I had run across this trick before. To get this little burr off, this little lip, all you do is pop this in the vise face down against the jaws and tighten the jaws, and it squeezes it right off, and you get a fairly clean edge. Just a little trick. Alright, so we have 3 pairs, including the first one I screwed up where I was way off to the side, and 2 others that are centered. And next up, we're going to put these in the vibratory tumbler and see how that works. We just loaded it up with abrasive media. We tossed the parts in. I'm going to put the lid on. And we'll come back in a couple hours and see how it's done. So we've been running 2 hours so we can shut it down. So the finish is actually really nice. And the little bits of stuff, they get absolutely everywhere. I got to pry these guys out of here. It's amazing. I didn't think they'd ever get in there, but look at how nice that finish is. Kind of looks like a combination between polished and sandblasted. It's really surprisingly good. So let me clean these guys up. We'll bring you back. So there's with some better light, and the finish is really nice. It's sort of this shiny, sparkly finish. And there's even some little green bits inside where the threads are. It's really amazing. It doesn't, like they said, it doesn't take off edges, so I purposely did not deburr these parts, and the burrs are still left. So I'll have to take those off manually, but that's kind of interesting. Overall, the finish is kind of neat, though. So next up, we're going to make the 2 squeeze brackets. One's thinner than the other. One is for the larger shaft and one's for the smaller shaft. We're going to start by drilling these holes because they're in the same place on each. 1/4 inch through hole and a 5/8 16th of an inch depth, or 62.5 thousandths depth countersink or recess that this part slides into. It's all about, actually goes this direction. It's an appearance thing because it'll make it appear to be, just perfectly blended with the surface. So there's really no useful feature for that. It's just for looks. So we're going to start with a center drill, then 1/4 inch, and then a 5/8 inch end mill. So next up, we're going to use the high-speed bit that I have in 5/8, and we're going to go really slow, about 150 RPM, and we're going to go in 1/16 of an inch. So I've set my 0 just by gently touching and using my quill DRO, and we're going to go. And we're there. So that gives you an idea. It's just, again, for appearance's sake. Makes it look like it meets up with the surface nicely. So the two identical parts are done. Now we're going to flip them on their side, and that's where the similarity differs, because one's got to be thicker than the other to deal with a larger shaft. And then we're going to slit them this way all the way down. Okay, we're done with the cross holes, and we're heading to the slitting saw next. And we will be slitting from here all the way to just before the end there. Okay, so we've got a 6-inch slitting saw blade, and I've got both pieces locked in the vise so that the vise doesn't cant only grab on one point, because it's grabbing it in a very shallow fashion because this one's really thin. I've got to go all the way into almost the very end on the back here, so we're going to go really slowly. So I'll probably bring you back and show you a couple passes maybe in between. This is going to be a long process, I think. I thought about doing it on my bandsaw, but I couldn't think of a good way to hold these parts, so I didn't want to risk it. So after, well, 10 passes, we're 90,000 steps. We started really light passes at like 3 to 5 thousandths. This thing's struggling on the tool steel. It really is. So I think I am going to try and do this in the bandsaw because this really isn't working out. For those that wonder, my speed is about 70 RPM. I looked at calculators and they said I could go up anywhere all the way up to 500, but there's just no way. So I went slower to keep it cooler, and it just really wasn't working out. So bandsaw it is. So here's the setup I'm going to use. I have got the block clamped in a machinist vise that's ground, and the part is flush with the base, or the side, I guess it would be. And I've got it centered on the blade. I started the cut over with the slitting saw, but that was going to take probably an hour and a half, 2 hours to do the slit, and it was really putting a lot of stress on the mill. It sounded like it was really working too hard. So rather than do that, we're just going to try the bandsaw. Hopefully it'll cut straight. We will go slowly, and I'll use lube. So we'll give this a shot. Alright, so here we go. I'm going to try and let you see. I've got the surface speed per minute about 150. It's pretty slow. So far, so good. It looks like we're cutting straight. I'm going to control the amount of tension. So there's the final job. It's not a perfectly straight cut. I wish it had done a little better. It's off by a few degrees. We'll try and make the next one better. Wonder how the big boys do it. So we're ready to assemble, but I think just to make the cosmetic appearance more pleasing, I think I'm going to round off this edge this way and flip this guy over and round this whole thing this way. The square part's not needed for strength. It'll just make it look a little smoother and nicer. So I'll do that and I'll be right back. So I almost forgot, the cinch on this side is 3/4 of an inch. This one's 3/8, and so I'm sorry, 3/4 and 1/2 inch. And so the through knob with the bolt on this side needs to be 1/4 of an inch shorter. They came 1 inch, which is what this side needed. So I'm going to use a fixture Tom Lipton recommended, which basically is a threaded portion that's slit. You just tighten this down, you set your depth, you tighten it down and it holds in place. You take it over the grinder and just cut it off. Very handy fixture to have. This is 2 different sizes, 3/8 and 1/4 20. And anyways, they're handy to have around. Every time you come up with a project where you need a new screw size, I just make a new one and make it double-sided so that it's even simpler. So we're going to take this over the grinder and we'll be right back. By the way, one more thing that's nice about this design is after you've ground it off, if you back it out with tension under it, it cleans the threads up for you. And then you can take it over and put a bevel on like I did. I screwed it back in, but anyways, here's the 3/4 knob, and we are ready to assemble these guys. All right, so the first step with these guys is, I'm guessing, just to put the bolt through and line these two guys up. Then you just thread the bolt into the bottom of the inside. And next is to put the set screw in. Okay, so next you put the set screw in, and you can thread it all the way through so that these are set screws that have a little brass bit on the end that's designed for pushing against the surface to protect it. And in this case, I'm just going to feed them all the way through. And now you'll see there's just a tiny bit of slack, which means it's going to make it really easy to feed the camera shaft down this guy because it won't have anywhere to go. Alright, so I'm going to assemble the other one. I'll bring you right back. So here are the two cinches or snugs put together, and they're ready to assemble on the camera bracket, and we'll see how they work because I'm really looking forward to this. I have this other one left over, but boy, when I screwed up, because not only did I drill this off center, but I forgot to tighten the 1/2 inch shaft side, so it rotated a bit, so it doesn't even line up perfectly. So this one's a total waste, but I guess a good learning experience. So I'll get the camera bracket together and we'll see it all in one final assembly. So here we are at the end, and I opted for a beefier knob on the base because with such a long arm, there's a lot of force trying to move this shaft, so that gets me pull this guy a lot tighter, but it's very, very smooth up and down both of these rather than really catching on this rough material, this hot rolled that the old one's made out of. All in all, I'm very pleased. Not only does it look better, but it works better. So thanks for watching. Hope you find it useful. Hope to see you next time. Here are the drawings for the project, and the first drawing is the thicker walled part that I did not make, or parts. And the next drawing is the thinner walled ones that I did make, including all the dimensions. And the final drawing is the assembly instructions and how to calculate how long the threaded parts of the shaft need to be. This project sure was more involved than I thought it was going to ever be when I started. It seems so simple, but there you go.